Hello everyone, and welcome back to my BPHO video series. In this video, we are going to go through question 1F from the 2018 British Physics Olympiad. Let's get started. First, let's read the question. A neutron moving through heavy water strikes an isolated and stationary deuterium, the nucleus of an isotope of hydrogen, head-on in an elastic collision. Question 1. Assuming the mass of the neutron is equal to half that of the deuterium, find the ratio of the final speed of the deuterium to the initial speed of the neutron. Question 2. What percentage of the initial kinetic energy is transferred to the deuterium? Question 3. How many such collisions would be needed to slow the neutron down from 10 megaelectronvolts to 0.01 electronvolts? This is a classic elastic collision problem. Let's define the initial speed of the neutron as u. After the collision, the neutron moves at speed v1, and the deuterium moves at speed v2. We'll also say the neutron's mass is m, and since the deuterium is twice as massive, its mass is 2m, just as shown in this figure. Now, applying conservation of momentum, mu plus zeros equals mv1 plus 2mv2. If we divide through by m, we get a simple equation, u equals v1 plus 2 times v2. Next, using conservation of kinetic energy for elastic collisions. The total kinetic energy before the collision is 1/2 mu squared. After the collision, it becomes 1/2 mv1 squared plus 1/2 times 2m times v2 squared. That simplifies to u squared equals v1 squared plus 2 times v2 squared. Solving these equations together, we found that the ratio of the final speed of the deuterium to the initial speed of the neutron is 2/3. Moving on to part 2, we want to know what percentage of the initial kinetic energy is transferred to the deuterium. The initial kinetic energy of the neutron is 1/2 mu squared. The kinetic energy of the deuterium after the collision is 1/2 times 2m times v2 squared. And since we found that v2 equals 2/3 of u, we substitute that in. So the ratio of energy transferred is 4 lines divided by 1/2, which is 8 lines. That means 88.9% of the neutron's initial kinetic energy is transferred to the deuterium. Now for part 3. After each collision, the neutron loses 8 lines of its energy, so only 1 line remains after each impact. To reduce the neutron's energy from 10 megaelectronvolts down to 0.01 electronvolts, we can set up the equation. 10 million electronvolts times 1 line to the power of n equals 0.01 electronvolts. Taking the logarithm of both sides, we solve for n, and we find that n is approximately 9.4. Since we can't have a fraction of a collision, we round up and say it would take about 10 collisions to reduce the neutron's energy from 10 megaelectronvolts to just 0.01 electronvolts. And that's it for the question. Thanks for watching. I'm Physics Michael, and I will see you in the next video.